this video, we're going to take a look at solving some pretty basic 1 and 2 step equations and inequalities. Now, the first thing to understand about an equation is that it's a statement of equality. So it's a statement that says that one side has the exact same value as another side. And I like to think about an equation like a scale. And one of the most important things to understand about solving an equation or an inequality is that anything you do to one side, you have to do that exact same thing to the other side. And really, I can do anything I want to the left side just as long as I do that to the right side. So for example, if I added 1 square to the left side, well, I would have to add 1 square to the right side, and that keeps it balanced. If I wanted to remove 1 square from one of the sides, suddenly that side is lighter, I have to remove the same amount from the other side as well so that it stays balanced. I could double this side and have the exact same thing here again, but in doing that I would have to double the other side, and I'd have 2 of what I have on that side. So as long as you are keeping each side balanced by doing the same operation to both sides, you're going to be in good shape. Now, one of the ideas of solving an equation is to figure out the value of a variable. What is it equal to? So let's say we're trying to find out what is the weight of one of these triangles. So we would have to do some things to get rid of all this other stuff so that I have just a triangle over here and see what it's equal to over here. Well, I want to undo that doubling of the last step, so I'm going to take half of what I have on each side. So I'm going to basically divide both sides by 2. And I want to get that triangle all by itself, so I'm going to take away these 2 squares. Well, if I take away those 2 squares on the left side, now the right side's too heavy. I've got to take away 2 squares on the right side, and now it's back to being balanced. So we're going to take a look at some examples of solving equations and inequalities and graphing their solutions. And we're going to also take a look at a couple of strategies for doing so. So we'll start out with something kind of basic, pretty much just a one-step, let's say n plus 5 is equal to 12. It's a pretty basic one-step equation, and think about what the goal is of solving this equation. The whole idea here is to get that variable all by itself, to isolate the variable on one of the sides. I want variable equals number. So one strategy I have is to highlight or circle or do something to highlight where that variable is. So I'm just going to draw a box around it and say that is all I want to have on the left side. Another strategy is, especially with more complicated equations, it's a good idea to highlight the left and the right side. So I'm going to draw just a line kind of down where my equal sign is. And that is going to separate this equation to a left side and a right side. And that way I know that when I'm doing something to the left side, that I also have to do it to the right side, and I won't get mixed up. So let's think about what we have to do. Well, this is n plus 5 is equal to 12, and I want this to be all by itself. I don't want this plus 5. When you're solving an equation, what you need to think about are inverse operations. So I have addition going on, and so the inverse of addition is subtraction. So I'm going to do the inverse of adding 5, and I'm going to subtract 5 from the left side. But to keep this balanced, I'm going to also subtract 5 from the right side. And always think about, what is this step actually doing? I have a lot of students that they'll write a step and then they'll jump ahead to what they think should be in the next step. But it's always important to think about, is that operation doing what you want it to do? So I have a positive 5, and I'm subtracting 5, and that is going to give me 0. So all I have on the left is n plus 0, and that's just plain n. I'm going to bring down that equal sign, and 12 minus 5 is 7, and now I have variable equals number. That appears to be my solution. What that means is if I take that value for 7 and substitute it back in for the variable, I am going to have a true statement. So it's always a good idea to check. I'm going to take that number 7, replace n, substitute it. So I have 7 plus 5 equals 12, and 7 plus 5 is 12. So it did work. That means that 7 is a valid solution. Now, graphing a solution is showing that in a visual way And since we have just one variable, we need one number line for that. So to graph this solution of 7, we're going to show that on this number line, just make sure that 7's on there, that is the only number that works. N is equal to 7. And to show that one number is a solution, you just make a closed circle right on that number. So that is a graph showing that 7 is the only thing that works. Just this one dot is showing that 7 is the solution. Let's take a look at an inequality. So if an inequality operates really the same way as an equation, but rather than the two sides being equal to one another, the two sides are going to have values that are different somehow. So here's an example of an inequality. 3x minus 6 is greater than or equal to 21. What this is saying is not that these two sides have the same value, but that this side could be equal to 21, or that this side could be bigger than 21. For this reason, there's not going to be just one solution, because there's a lot of ways to make this side bigger than 21, as well as the one way to make it equal 21. So I'm going to go ahead and use that strategy again of highlighting the two sides. Let's get a little color in here. So I'm going to go ahead and highlight where I have the left side and the right side. And you may not need to do this. You might be good enough at solving equations where you don't need this strategy, but it's definitely worth it if you're having trouble. Let's think about what I want to get rid of or what I want to keep. On the left side, this x, that is the variable that I want all by itself. So what I know is I have to get rid of the 3 somehow, I have to get rid of the minus 6 somehow, so I have to do opposite operations. Think about what operations are going on. I have 3 times x minus 6, so I'm going to have to undo multiplication and I'm going to have to undo subtraction. So let's go with let's say you'd want to undo this multiplication first. So I have 3 times x. The inverse of multiplication is division. So I'm going to divide the entire left side by 3. And I'm going to divide the entire right side by 3. It's just like we had that scale. We just divided each side. So I'm allowed to do that. The important thing to know is you're dividing that entire side. So 3x divided by 3 is just x. And negative 6 or minus 6 divided by 3 is minus 2. Is greater than or equal to 21 divided by 3 is 7. And the inverse operation to this minus 2 is to add 2 to both sides. So x is greater than or equal to 9. Graphically, what this will look like is we have to show a couple things. First off, we need to make sure 9, that's going to be the boundary, is on there. To show that our variable could equal 9, we're going to have a closed circle at 9. That shows that x could equal 9, but we also need to highlight that it could be bigger than 9. So think about what direction on this number line do the numbers get bigger than 9, and that's to the right. So you're going to shade or draw an arrow to the right side, and that's graphically showing that 9 and anything above 9 will make this a true statement. Let's go ahead and check it. Let's check 9. So if you take 9 and substitute it in, we should get a true statement. So 3 times 9 is 27. And 27 minus 6 is 21. And 21 is greater than or equal to 21, so it worked. But if you pick a number that's bigger than 9, it should also work. So let's take 10. Oops, that should be 21. There we go. So 30 minus 6 is greater than or equal to 21. Well, that's going to be 24 is greater than or equal to 21. And that works as well. So 9 and anything bigger than 9 made this statement true. I want to take a look at another example here. When we're dealing with inequalities, it's always important to know this one extra sort of thing. So let's get a inequality here. Negative 4n plus 12 is less than or equal to, let's not do less than or equal to, let's just, that's fine. Less than or equal to 16. So I'm going to go ahead and use that strategy again where I'm going to highlight or separate the left side from the right side just so I know that I'm doing the same thing to both sides. I'm also going to use my strategy of circling or highlighting the variable I'm trying to isolate. because that's going to tell me everything else that I'm trying to get rid of. I'm trying to get rid of that -4 and that +12. Now last time we divided first, let's go ahead and get rid of that +12 first. And we're going to do that by subtracting 12 from each side. So positive 12 minus 12 is 0. And we just have -4n on the left side is less than or equal to 16 minus 12 is going to be 4. And we have to undo that multiplication with its inverse, which is division. So we're going to divide that entire side by -4. That's going to give us -4 divided by -4 is just 1. So I just have 1n. On the right side, 4 divided by -4 is -1. And anytime you have divided by a negative or multiplied by a negative, you must flip that inequality sign. So it's going to change from a less than or equal to a greater than or equal to. Let's go ahead and graph this. So let's put -1 sort of in the middle of that number line. That's our boundary. A closed circle will show that we can have -1. It's a valid solution. And what direction do the values get bigger than -1? That's going to be to the right. So there we have a graphical solution of that. So that's an important thing to remember. Whenever you divide by a negative or multiply by a negative, you must remember to flip that inequality sign. So it's a good idea to check. So let's go ahead and check the solution. I'm going to check -1. So I'm going to substitute in -1. That's closed, so it means it should be a solution. So -4 times -1 is 4 plus 12 is less than or equal to 16. So 16 is less than or equal to 16. Yep, that worked. Let's check a number that's bigger than -1. So let's try a 0. So -4 times 0 plus 12 less than or equal to 16. Well, that's 0 plus 12. So 0 plus 12 is 12 is less than or equal to 16, and that one worked as well. So those solutions are valid. That shows that this graphical representation is good, that -1 or anything bigger makes that statement true.